Hello, my name is Earth Philosophy and today I am going to explain how the South Celestial Pole works on flat Earth. Let's begin. In my last video I derived an equation that explains how the light coming from Polaris bends so that Polaris appears to be at different altitudes in the sky depending on the observer's distance from the North Pole. I mentioned that globe earthers assume that light travels in straight lines and that it is the Earth that bends, but on flat Earth we can assume that it is in fact the light that is bending and not the Earth. Our observations tell us that the apparent altitude of the South Celestial Point depends exactly the same way from the observer's distance from the South Pole as the apparent altitude of Polaris depends on the observer's distance from North Pole. This means that we can use the same equation that we derived for Polaris to calculate the path light would take if it came from the South Celestial Pole. Here is a 2D simulation for the light that would come from South Celestial Pole. We can see here that with this model two observers looking at opposite directions would be able to see the same star, or in this case the South Celestial Pole. But this is not all. If we expand our model into 3 dimensions we can see how the observations of both Polaris and the South Celestial Pole can be explained using one function. Here the green circle represents the flat Earth and the red represents the path light coming from either Polaris or South Celestial Pole would take. With this model we can explain how people on the southern hemisphere can all see the South Celestial Pole when looking towards the edge, or the so-called South Pole. There it is, a working explanation for both Polaris and South Celestial Pole on flat Earth. If you find anything wrong with this explanation, let me know. I will continue creating a working flat Earth model, so if that's something you are interested in, why not stick around?